Hey guys, we're going to be talking about determining empirical and molecular formulas.
Alright.
Okay, so I think the best way to do this is to go ahead and jump in, and I'm going to show you some problems here. So the first one we're going to be solving for an empirical formula. Okay, so I'm going to talk about what that means after we've solved this problem. So it says a compound has 3 moles of hydrogen and 1.5 moles of oxygen. What is the empirical formula?
So where do we start?
So we're going to start by finding which one has the least amount. So oxygen has our least amount.
Yeah, I got 3 and we got 1.5. 1.5 is definitely smaller.
So in order to figure out our ratios, which is what we're going to be looking for, we've got to divide the different amounts by our smallest amount. So let's start with our hydrogen. We have 3 moles of hydrogen.
All right. So we put that right here.
Okay.
And we're going to
divide it by our smallest amount, which is
1.5.
1.5. So 3 divided by 1.5
comes out to 2.
Okay. Now we've also got to do the same thing with oxygen. It's 1.5 divided by 1.5.
Well, if we divide the same thing by itself, isn't it just
1? Yes.
Okay,
so this empirical formula is a fancy way to say the ratio formula. We're just figuring out a ratio of how much hydrogen mass we have to how much, or oxygen, well, moles, not mass, rather. So we have a ratio of 2 hydrogens for every 1 oxygen. So we're going to write that as subscripts for our formulas. So H
gets the 2.
Gets the 2.
And O gets the 1. Well, we don't have to put anything.
Write a 1. Right. So our empirical formula is H2O.
Wow.
Okay?
That's water.
Yes, exactly. Now, we need to calculate the molecular formula, okay, using the empirical formula.
So the empirical formula here is just kind of like a practice formula, and then the molecular is like the actual one?
Right. So the molecular formula is actually how many atoms of each there are. And we use the molecular mass to figure that out.
And the molecular mass is just the same thing as the molar mass?
Molar mass, yes.
Okay.
Same, the mass off of the periodic table.
Gotcha.
Okay, so now let's take a look at this second example we've got. We have the empirical formula for our compound is NO2. So that's like what we just solved for. That's the ratios.
Okay. So we got 2 oxygens to 1 nitrogen.
Right. So the molecular mass of the compound is 92 grams per mole. What is the molecular formula? Okay, so whenever we have a molecule, we calculate the molecule's mass off the periodic table, it'll be 92 grams per mole. Okay, so what we're going to do here, we're going to start off by finding the molecular mass for NO2.
We got to find the molar mass of our practice one.
Right. So nitrogen, we look on the periodic table, it's got a molar mass of 14 whenever we round it.
Okay.
Oxygen, we know, has a molar mass of 16.
After we round.
So, but we've got 2 of them here, so we have another 16.
So we just can multiply that by 2.
Or times 2. Same difference. So the molar mass of NO2 is going to be 46 grams per mole. Okay. Put that paper up a little bit there. Okay. So 46 grams per mole is the molar mass of NO2. But that's not how many atoms there are in a real molecule of this.
Yeah, so it says it's 92, so that's a lot heavier.
Right, so we've got to figure out how many more atoms, how many more NO2s we need in order to have the real molecule. So we know the molecular mass of the real molecule is 92. We're going to take that and we're going to divide it by the molar mass of our little practice one.
Okay.
And we divide those 2 and we'll get 2. So that means in our real molecule we have 2 NO2s. So our formula for the molecular formula is going to be N2O4. So
we just multiply everything in here by 2. By the 2 that we got there.
Right.
So we have N2O4.
4.
4.
Okay?
Wow.
All right. So now if you think you understand this, I want you to pause the video and take a look at the guided practice problems. Try them yourself, and then I'm going to work through 2 problems again, and you can check to see if you did. If you're completely lost still, watch me work through the guided practice problems. Okay, so we have your guided practice problems here. So, a compound has 0.5 mole of K, 0.5 mole of N, and 1.5 mole of O. What is the empirical formula?
Okay, so it says up here that to find the empirical formula is just the ratio, right?
Right.
To find the ratio, we divide the number of moles by the
smallest number of moles. Okay, so we have, what's our smallest number of moles here?
I'd say it's 0.5. 0.5 is definitely smaller than 1.5.
Right. So we've got to find our ratio of K, our ratio of N, and our ratio of O by taking the given moles of each of those, which K is 0.5.
Right.
And we're going to divide it by the smallest amount, which is 0.5.
And whenever we divide anything by itself, that's just 1.
1.
So that's that ratio.
Okay. N is going to be the same thing. It's 0.5 divided by 0.5.
That was
Also 1. Now oxygen, it's 1.5 divided by 0.5. And if you plug that in your calculator, you'll get 3. Okay, so those are my ratios. So now I just plug those in, rewrite my formula with that number of atoms for each. I've got 1 K, I've got 1 N, and I've got 3 oxygens.
Oh, you got K and O3.
K and O3.
That's it.
Okay? Now, let's take a look at that empirical formula. So the empirical formula for CH2, or for a compound, is CH2.
Okay.
The molecular mass for the compound is 46 grams per mole. 56 grams per mole. What is the molecular formula?
So you've got the ratio one, and we need to find the actual one.
Right. The empirical is the ratio.
So that means that we need to find the molar mass of the ratio one first.
Right. So we're going to start by finding the molar mass of carbon, which is 12, if we look at that on the periodic table, rounded, of course. And the molar mass of hydrogen, one hydrogen is going to be 1.
Well, we got 2 of them.
We got 2 of them, so we'll go ahead and call that 2. Or 1 times 2 is 2. Okay, so then we add those up, and our molar mass of CH2,
that would be 14.
Is 14.
14 grams per mole. So that's our ratio one.
Right. But we know our compound has a mass of 56 grams per mole. So we're going to take the 56 and divide it by 14 now.
Okay. 56 over 14, and then you put it into a calculator.
You get 4.
All right.
Okay.
So then we multiply each of these in our practice one, the ratio one, by 4.
So we've got 1 carbon, so 1 times 4 is 4. C4, and then we've got 2 hydrogens, so it's H8. 2 times 4 is 8. And that's our answer.
That's it. That's our molecular one.
Yep. Okay. Well, time for you to try some practice problems on your own.